Hello, my name is Matthew Bergantz, and my topic is coral reef deterioration. So to talk about coral reef deterioration, I think it's important that we first talk about what exactly coral is. Coral is made up of hundreds of thousands of tiny organisms called coral polyps, pictured here. They attach themselves to rocky reefs in large colonies and feed on microscopic zooplankton through a tiny opening here, which also expels waste and is used for defense and to clear away sediment. These colonial organisms bind together to form large, intricate corals in many shapes and sizes all around the world. Pictured here, you can see some brain coral, some flat coral, some fire coral, and in a picture here, they all live together on a reef. This next picture demonstrates where exactly coral exists in the world, mostly tropical regions. Some coral are sharp and rocky, while others are soft and fleshy. Large reefs provide a plethora of life for thousands of aquatic species, from predators like sharks to small prey like krill and shrimp. Here you can see an example of many forms of life that thrives in coral reefs. In fact, reefs support up to 25% of all marine life. World famous reefs like the Great Barrier Reef in Australia, Molokini in Hawaii, and the Amazon Reef in South America are beautiful examples of the best types of man-environment interactions. We're able to observe and appreciate these ecosystems all over the world. However, our reefs are now under threat by anthropogenic warming. Climate change threatens our planet in many ways, from the rise of global temperatures to the resurgence of potential superbacteria. There are plenty of things to worry about when it comes to man-made climate change. Massive carbon emissions and negligent pollution, shown above, on a large scale since the beginning of the industrial era have contributed to the decimation of rainforests and other historically thriving ecosystems around the world. Rainforests in South America and Southeast Asia have been clear-cut, pictured above, for mining and lumber industries. Other factors like overfishing, pollution, and harmful environmental practices threaten our reefs. Carbon emissions create a greenhouse effect in the atmosphere, and as a result, the whole planet begins to warm, hence the term global warming. We all know what that is by now, so I won't get too into it, but this affects the ocean in many ways. The polar ice caps are beginning to thaw, and sea levels will rise, threatening millions of people's lives and homes along the coast. Warming also threatens fragile ecosystems with species extremely sensitive to temperature. NASA recently reported that global sea temperature increase by just 2 degrees Celsius will end virtually all tropical coral life by the year 2100. That year is important. 2100. Other anthropogenic issues facing the ocean that also impact life in coral reefs are ocean acidification and plastic trash pollution. Ocean acidification occurs because carbon dioxide is absorbed by the ocean. This causes reaction upon reaction, creating carbonic acid, eventually limiting the supply of calcium carbonates in the ocean water. Carbonates form the skeletal structure to rocky corals and the shells to crustaceans, crabs, lobsters, shrimps. With carbonates in limited supply, budding shellfish and oysters cannot create shells they need to survive. Plastic pollution also greatly affects life near coral reefs, but that is a topic for another presentation. Bleaching is the most threatening aspect of anthropogenic warming to coral reefs. Warm ocean temperatures and acidity strip away the chemical compounds that give coral its bright, beautiful colors we know to love and expect. Acidity causes the skeletal structures of calcium carbonate to become compromised and break down. Warm temperatures cause corals to expel vital algae living in their tissues. These tissues provide the bright, beautiful colors. As the infographic by Noah here shows in the slide, the algae leaves the coral when it becomes too stressed, leaving the coral a bright white color. Not only does this mean the coral is stressed and more susceptible to disease, but it impacts the entire ecosystem around it. Bleaching threatens thousands of species of fish who rely on coral reefs for food and shelter. Consider the rainforest of the sea because of the massive biodiversity that coexists in the ecosystem. This title is under threat because of the loss of biodiversity occurring as a result of bleaching and acidification. Here in the slide, you can see bright colored fish against the white bleached background coral. I was able to see this firsthand on a scuba trip to Mexico last summer. The fish stood out just as they do now. And if we can see them, predators can definitely see them. As I mentioned earlier, temperatures threaten all tropical coral life by the year 2100. But in 2016, bleaching of coral on the Great Barrier Reef killed between 30 and 50% of the reef's coral, according to a study by the UN Environment Program. Coral calcification diminished by 15% since 1990 and is in danger of reaching almost 80% by the same year, 2100. This means we have less than 100 years to combat global oceanic temperature rise and ocean acidification, or we risk losing our coral reefs forever. I don't even want to know what that means for the rest of oceanic life. I love sharks. If there was no more Shark Week, I would lose it. 100 years sounds like a long time, but really it's much less than you might realize. That's why groups like the Coral Reef Alliance and Fight for a Reef have taken action on behalf of our coral reefs. These conservation organizations work hard to ensure the safety and development of innovative solutions to combat coral deterioration. Pictured above are coral restoration techniques, farming and seeding, which are funded by conservancy groups and developed at local and university levels. In turn, these groups share seeding and farming techniques to help replenish endangered ecosystems. Coral Reef Alliance also helps fight for policy change in developing nations where industrialization trumps environmentalism and pollution regulations are minimal. Pictured in this slide are examples of farming as produced by the Coral Reef Alliance in Australia. You can see particularly here this one growing and successful methods. Another radical solution has presented and engineered by the Dutch maritime firm Boskalis and engineer Fabien Cousteau. They successfully implemented a 3D printed reef off the Florida Keys in the Persian Gulf and Bahrain. However, barriers do exist to farming and 3D printing. Artificial reefs don't always fit in their environments. Those are reefs that are farmed and seeded by man. They've failed to successfully sustain life. Cavities in small spaces are vital to smaller organisms. This is more difficult to do by hand. Farming works as long as the sea conditions remain constant. But this is a struggle as long as climate change continues to affect oceans and ecosystems. 3D printing, however, is considered a widely successful method of replenishing coral reefs. In conclusion, our coral reefs are under direct threat by anthropogenic warming and human activity. The solutions are up to us. Awareness and action are vital to saving our reefs within the next 100 years. Thank you.